In September 2020, across the arid landscapes of New Mexico, biologists witnessed a massive biological catastrophe. Tens of thousands of migratory birds suddenly fell dead from the sky. An unseasonably cold storm had caught them mid-migration, starving them in flight. Dr. Martha Desmond, a wildlife biologist at New Mexico State University, led recovery teams to document the loss. They expected to find the desert floor carpeted with small bodies. Instead, they found almost nothing. The ground was completely clean. Thousands of animals had died in a single night, yet their physical remains had vanished within hours. Why does a world populated by billions of birds remain so devoid of their bodies? The common explanation is that birds simply fly somewhere remote to die. This is wrong. The absence of avian remains is the result of an evolutionary mechanism called competitive nutrient cycling. In the natural world, a dead bird is not trash. It is a highly concentrated package of rare proteins, calcium, and lipids. Because these resources are scarce, ecosystems have evolved a hyper-efficient system to claim them immediately. It is an economy where nothing is permitted to sit idle. In nature, death is not an end state, but a transaction. To measure the speed of this economy, Dr. Travis DeVault, a wildlife biologist working with the Savannah River Ecology Laboratory, conducted a controlled ecological experiment. DeVault and his research team wanted to see how long small carcasses remained in the environment before being consumed. They placed 120 small animal carcasses, including several bird species, across various forest and field habitats. The results were immediate. Within 24 hours, scavengers had claimed over 60% of the remains. In many cases, the carcasses vanished within a single hour of being placed on the ground. This rapid consumption was driven not just by large mammals, but by a massive array of ants, beetles, and wasps. DeVault's research demonstrated that the sheer speed of scavenging makes it almost impossible for a casual human observer to stumble upon a dead bird. The carcass does not rot in place. It is actively moved, disassembled, and digested by a highly specialized community of organisms known as the necrobiome. This microscopic and macroscopic network of consumers is constantly watching. They wait for the cessation of movement. The forest is always hungry. It does not tolerate waste. To understand why this happens so quickly, we must first look at the physical architecture of the bird itself. Consider the ruby-crowned kinglet, a tiny songbird that weighs just 6 grams. Its entire biology is optimized for flight, which requires extreme weight reduction. Birds do not have the heavy, dense bones of mammals. Instead, they possess pneumatized bones. These bones are hollow, thin-walled, and reinforced with internal struts. To humans, a bone looks like a permanent structure that should last for decades. It isn't. When a bird dies, these delicate, air-filled structures offer no resistance to the elements. They are easily crushed by the step of a small rodent or broken apart by heavy rain. Furthermore, bird feathers are made of beta-keratin, a tough structural protein. While keratin resists water, it is highly vulnerable to a specialized group of fungi called keratinophilic fungi. Species like those in the genus Onagina target the feathers immediately, digesting the protein chains within weeks. Combined with soil acidity, the entire skeleton of a small songbird can dissolve into the earth in less than 28 days. The body is digested by the earth itself. Their physical form is temporary. After a month, nothing remains of their skeleton except for a tiny patch of enriched soil. Their bodies are engineered for the sky, not the soil. This rapid physical decay is preceded by a highly specific evolutionary behavior. Birds rarely die in the open because they actively hide when they are failing. Dr. Benjamin Hart, a veterinary scientist at the University of California, Davis, documented that animals across species lines share a highly conserved set of responses known simply as sickness behavior. When a bird is injured or suffering from a pathogen, its brain triggers a complete behavioral shift. It becomes lethargic, its body temperature drops, and it experiences an intense drive for isolation. This is called sickness-induced crypsis. A sick bird does not remain on an open branch where it can easily fall to the ground. It seeks out the deepest cover available. It wedges itself into dense brambles, hollow tree cavities, thick ivy, or backyard woodpiles. It fluffs its feathers to trap remaining body heat and stays completely still. This behavior is not a conscious search for a grave. It is a defensive strategy designed to hide the weakened animal from predators. Because the bird remains in these impenetrable natural cavities, it eventually dies there. By the time life leaves the bird, its body is already secured inside a hidden tomb of wood and leaves. Human eyes rarely penetrate these deep spaces. This is why we never see the transition from life to death. In nature, death is not an end state, but a transaction. Many birds never get the chance to hide because they are harvested while still alive. A massive portion of avian mortality occurs through active predation. In the United States alone, domestic and feral cats are estimated to kill up to 3.7 billion birds every year. Birds of prey, such as Cooper's hawks and sharp-shinned hawks, take millions more from the sky. When a predator catches a bird, the carcass is rarely left intact. Hawks use their sharp beaks to pluck feathers, which are quickly scattered by the wind. They consume the meat, organs, and even the smaller bones. Larger bones and indigestible materials are packed tightly inside the gizzard and later regurgitated as highly concentrated, compact pellets. These pellets are dropped far from the kill site, where soil microbes break them down in days. Mammalian predators like foxes and raccoons eat small birds whole. They digest the bones entirely in their highly acidic stomachs. The bird is processed and converted into energy before its body can ever touch the forest floor. The bird does not become a static corpse on the lawn. It becomes a dynamic fuel source for another creature. It vanishes mid-flight. For the birds that do die of natural causes and fall to the ground, a subterranean cleanup crew is waiting. Burying beetles of the genus Necrophorus are among the most efficient undertakers on the planet. These insects can detect the chemical signals of a dead bird from over a mile away using highly sensitive receptors on their antennae. Once a male and female beetle locate a carcass, they immediately begin excavating the soil beneath it. Within hours, they can bury a bird several times their own size, up to 3 feet underground. They strip the feathers, coat the body in oral and anal secretions that inhibit bacterial decay, and lay their eggs nearby. This preserves the meat as a private nursery for their larvae. If the beetles do not find the body, forest ants will. A colony of common pavement ants can reduce a small bird to a clean skeleton in under 48 hours, carrying the nutrients deep into their subterranean chambers. What looks like a vacant forest floor is actually a highly active, competitive market of insect labor. They dismantle the evidence of mortality with mechanical precision. No scrap is wasted. They pull the energy back down into the underground food web. This microscopic efficiency is not just an interesting quirk of biology, it is a foundational pillar of entire ecosystems. When we look at the disappearance of wild birds, we are seeing the vital mechanism of nutrient cycling in action. If these carcasses accumulated on the ground, they would become breeding grounds for dangerous pathogens, threatening both animal and human health. We know this because of what happened in India in the late 1990s. The widespread veterinary use of the anti-inflammatory drug diclofenac accidentally poisoned millions of vultures, causing their populations to crash by over 99%. Without these primary scavengers, cattle and wild animal carcasses began to pile up across the landscape. The cleanup network failed. The resulting accumulation of rotting meat led to an explosion of feral dog populations, which in turn caused a massive spike in human rabies cases, costing the Indian economy an estimated $34 billion. The collapse of a single tier of scavengers paralyzed the entire system. It proved that the invisible disposal of bodies is a critical public health service provided by the wild. When we look at the clean ground in our forests, we are looking at a system working exactly as it should. Every time we walk through a park and see only green grass, we are witnessing a quiet, violent triumph of evolutionary economics. In the natural world, death is never a final state, but a constant transaction.